9. You got 10 students in a graduate program that were randomly selected. Their grade point averages when they entered the programs were between 3.5 and 4 point. They're right here. And then they have their current GPA listed. So they want us to find the linear model that best fits the data. So in your calculator, you want to, I'm going to clear this out, push stat, enter, and then I'm going to record the data in L1 and L2. Now I already have some stuff there, so what I'm going to do is go to the top and push clear down. That clears out the entire list. I don't need L3, but I may as well go ahead and clear it while I am here. Alright, in L1 I'm going to put the entering GPAs, so it would be 3.5, whoops, it's not letting me type, 3.5, 3.8, 3.6, 3.6, 3.5, 3.9, 4.0, 3.9, 3.5, and 3.7. Well, 3.9, 3.5, and 3.7. And then on the next row, it's their current GPA, and I'm just going to copy what's in the table. Hopefully I don't make any mistakes. And take a second to catch up here. You can always check and make sure what you've got in the number that you have in one column matches the number that's in the next. All right, find the linear model that best fits. So stat, arrow over to calculate. I want the linear regression, so I'm going to choose 4. And this says my X list is L1. Right now this says my Y list is L3 because I was doing something else the other day, so I really need my Y list to be L2. So if you look right here above the 2, do you see that L2 right there? So if I push second 2, it'll change that to L2. There's not a frequency list. I am going to store my regression equation in Y1 just because I might want to use it. So go to vars, arrow over to Y vars, enter. I'm going to tell it to put it in Y1. You don't have to do that, but it sometimes can help. So calculate. So Y equals, it asks me to round to 4 decimal points. So that'd be Y equals, I don't know if I can write on here. It's not, yeah, Y equals 0.031. It'd be 3x plus 3.6744 if I rounded correctly, because you look at the number right after that fourth one, and if it's 5 or larger, you round that fourth number up. So that's my equation. That's part A. What's the correlation coefficient? Oh, I don't see a correlation coefficient here. That means I've got to go back and make sure I have it set up to do correlation coefficient. Remember, the closer it is to 1 or -1, the better a fit it would be. So what I'm going to do is turn the diagnostics on. Okay, so since I didn't see anything that listed my correlation coefficient, that means I didn't have my diagnostic turned on. And typically you wouldn't turn your diagnostic on for most things that you're going to do. But if you go to the catalog, which is second 0, and scroll down to get to the D's, or a quicker way, do you see the letters right above here? Do you see that D is right here? If I click that button, it takes me to the top of the D's. So then scroll down until you see diagnostic. It'll say diagnostic on or diagnostic off. So I want to find diagnostic on. Then we'll go right back through the steps that I took. I went too far. Sorry. So you hit enter, and when you hit enter, it pastes it to the home screen. I apologize for these being here, but it pastes it to the home screen, and then you have to hit enter again, and it'll say done. Alright, so now the diagnostic's on. I'm going to go back to stat calc 4. It has my L list L1, X list is L1, Y list is L2. I'm not going to tell it to store the regression equation because it's already stored there. So I'm going to calculate it, and now not only does it give me A and B, but it also gives me the correlation coefficient, which is 0.043. You know what that means? That means it's not a really good fit. The R, the correlation coefficient, 0.0430 if I round to 4 decimal places. That means it really should be close to 1 to be a good linear fit. When they're close to 0, like this one is, it means the numbers are just scattered about, and you can't really use one to predict the other. So I would say that's not a good linear fit. And if you were to take a look at this graph, which I'd have to make sure my scatter plot's turned on, it's not. So plot 1, I'd turn it on. And the best way to fit my model of data is to hit zoom 9, because that takes my stuff that's in my stat. And if you'll look, you see here's the line that we came up with, and these are all the points. You can kind of see that incoming GPA may not be a a good predictor for current GPA. That's kind of what that tells us. But use the model to predict the current GPA for a student with an entering GPA of 3.0. So if I'm going to give it the X, I want it to give me the Y. So I'm going to go down here. I went to second window, if you're wondering when I click second window. And instead of this being auto, I'm going to change it to ask. I'm going to go to my table. And the X values were the entering GPA. So I'm going to put 3.0. And it tells me that the current GPA, I don't know why there's something also in Y2, but I don't know why. I can clear that out. Must have been in there from the other day. So if I go back here, when the entering GPA is a 3 point, by this model it says the GPA would be a 3.8 because you want to round to the nearest tenth. So my answer to part D would be 3.8. All right, let's take a look at number 10 if we can. I need to clean this off right quick. All right, in question number 10, they want us to graph this function, and they also give us the window that we're going to use. So let me go back over to the calculator and type this in. So on my calculator, I want to go to the y equals, and I'm going to type in the function, clear what's there, and it's x to the fourth. And then make sure you go back down. You don't keep it up there in the exponent, plus 2x cubed, and then minus 25x squared. Oops, 25x squared. I just messed that all up. Delete, delete, delete. And then 25x squared. And then minus 26x plus 120. And I'm not sure why this exponent is not going away, but okay, there it is, plus 120. So x to the fourth plus 2x cubed minus 25x squared minus 26x plus 120. They give me the window setting so that I can see it. So it tells me my x min is supposed to be negative 10 on that page right there. And my x max is supposed to be a positive 10. For the x scale, we're going to leave it at 1. Y min, negative 75. Y max is going to be 150. And Y scale, we're going to put it at 10. And Y res, we're going to put it at 1. So I'm going to take a look at this graph and see what it looks like. Okay, we got something going on here. You know what that is? That's our scatter plot I forgot to turn off. So let me graph it, and then I'm going to go here in my scatter plot. Second Y equals. Turn that scatter plot off because I just want to look at the graph that I graphed. Okay, so they gave me the window. I have the graph. And here we have a look at it. The first question says, find all the zeros from left to right. So I'm going to find the zeros. Second trace, I want the zeros, which is number 2. And I'm going to come over here to this one on the left. And what you have to do is you have to give it a left bound and a right bound to calculate that zero. I'm going to have to do this 4 times. If you notice, there's 4 zeros here. So left bound and a right bound. So a point to the left of that and to the right of that. And that first 0 is at negative 5. So I would write negative 5, 0. Then I'll do it again. Second trace, 0. Move over a little bit farther, closer to this one. I need a left bound and a right bound. And I would get negative 3 as a 0. So negative 3, 0 would be your second answer. And then I've got 2 more to do. And it looks symmetric, but it's not quite. It's not centered at 0. So it is symmetric. It's just not, it doesn't have the y-axis as my line of symmetry. Left bound and right bound. So another 0 is at 2. So 2, 0 would be a third answer. And then second trace 2, another 0 would be, you can kind of tell on your graph it's going to be 4, but I'm going to go ahead and go through the motions for you guys. This other 0 would be at 4. Another way you could do it, my table is on ask right now, but if I were to change it to auto, what I could do is I could look through my table and see if I can see any zeros. And you can see these 4 zeros, negative 5, negative 3, negative 2, and 4. So over here in these first blanks, it would be negative 5, 0. Was it negative 3, 0, positive 2, 0, and 4, 0. Whoops, I didn't spell this next thing right. Find the relative minimums going left to right. It should be relative, not relatives. All right, so there's two minimums. If I'm looking at this graph, there's one here and one here. So to find the minimum value, second trace, and we'll find the minimum. And we'll move over here to the left. I was close to that other one. I should have done it. But it said going left to right. I'll follow directions because that'll make it a little bit easier to grade. So I need a left bound and a right bound. And the minimum value is negative 49, and that happens when x is negative 4.14. So y equals negative 49 when x is negative 4.14. Now I'm going to do it on the other side. So come back here. I know this video is going a little bit long, but I got to get this problem in. A 3. I have to give it a left bound and a right bound right quick. Alright, left bound and a right bound. Enter. So there's another one at there's a minimum negative 49 when x is 3.14. So negative 49 and positive 3.14. Alright, now relative maximum, there's only one of those. So back over here, second trace, this time I want a maximum value. So that's going to be number 4. Got to move over this way. I need a left bound and a right bound. Okay, so left bound and right bound. And enter. I've got a maximum value of, looks like 126.56 when x is negative 0.5. 126.56. 126.56 when x is negative 0.5. Give the domain of the function in interval notation. Alright, take a look at this. Domain is all real numbers. There is no denominator. There's no even roots. So my domain is going to be from negative infinity, and I put a parentheses there, to positive infinity. Range is a little bit different. The range is the lowest point to the highest point. And this is as low as it's going to go. It's not going to go any lower than this. And if you look over here, we wrote how low that was. It was negative 49. And it touches negative 49. It's going to keep going up to infinity. I know here it stops, but on these two sides, it'll keep going. So the range is going to be from negative 49 with a bracket, as it touches that point, to infinity. And infinity always gets a parentheses. Alright, when is it decreasing and increasing? Look at the chart. Look at the graph. It's decreasing until you get to here. So from negative infinity, let's see, decreasing, from negative infinity to negative 4.14, and then it's increasing from negative 4.14 to negative 0.5, and we always do parentheses with decreasing and increasing. And then it's decreasing again from negative 0.5 to 3.14, like right in here, it's decreasing. Between negative 0.5 and 3.14, it's going down. And then from 3.14 to infinity, it's going to be increasing again. Increasing from 3.14 to infinity. Alright, I'm going to stop here. That's a pretty long video for these two problems.